Hey guys, welcome to another video. Today, another video in the final question series that I've been doing. So today's video comes from the Extension 1 syllabus from 4th Street's 2024 trial paper, the final question. Now, the question itself has 3 parts and it's 7 marks, guys. 7 marks out of 70. This is 10% of 4th Street's trial paper. So quite hefty, quite important. Make sure you can do this. The topic it relates to is trigonometry. Now, I don't actually think this question is that hard, even though it's the last question, it's worth 7 marks, but it can look intimidating, right, in terms of the structure. So let's have a look. Now, before we do that, as always, guys, subscribe to the channel if you haven't already done so. Tell your friends and then like the video at the end, right? So let's get started. Let's have a read. So 4th Street 2024, first part. Okay, let's highlight key components. Show that the solution of this, right, where it's acute, is given by that. So that's what I have to show, right? That sine is the solution. I may use cos 3. Okay. So I don't think that's summing products. I think it's literally subbing that and then subbing double angles, right? I don't think that's anything fancy. So let's keep going. Without using that, show that x equals to pi 10 is a solution. Okay. And then prove that. Okay. Feels like 3 distinct parts. Okay. All right. So let's move over here. Let's have a crack. So part 1 was cos 3x minus sine 2x equals 0. Right? Okay. Now they're telling me to replace this with, was it 4 cos cubed, 3 cos, okay. 4 cos cubed, 3 cos, okay. So that's this. Yep. And if you're smart about it, at the same time, you basically replace this with double angles, right? So double angle for sine would be 2 sine cos. Yep. Now, feels like once I've done that, I can factorize cos out from all of them, right? Yeah, certainly possible. So let's do that, right? Factorize cos from all of them. Let's see what you get. You get 4 cos squared x minus 3 minus 2 sine x, right, equals 0. So it feels like I can solve 2 parts now. This side here is harder, right? This side here, it's not quite complete, but it looks like a quadratic. So I probably need to turn this into sine squared, right? So use 1 minus sine squared there as the identity to help me solve that, right? To get a quadratic in terms of sine. So I'm going to say this bit here gives me 0, and then this bit here gives me 0. So cos x equals 0, and 4 1 minus sine squared minus 3 minus 2 sine x equals 0. Now on this side, x equals to what? Pi on 2, 3 pi on 2, etc. What's my domain again? Domain is 0. Okay. So none of those, there's no solution there, right? Because it has to be less than pi on 2, so no solution here. Okay. On this side, at least. That's relevant for this domain. Okay. Now, on this side, let's see what I have. It's got minus 4 sine squared minus 2 sine x. And 4 minus 3 is plus 1 equals 0. Let's put the quadratic where there's positive sine squared. Let's put in the formula. Minus b squared minus 4ac all over 2 times a. Okay. Now, just looking at this bit here, what's that, guys? That's like 16 plus 4. That's 20, is it? Yeah, so root 20 is 2 root 5 all over 8. Divide everything by 2, so you get -1 plus minus root 5 on 4. Therefore, sine x. Now, since the angle is acute, right, in the first quadrant, sine has to be positive, so it can't be the negative case, so therefore, sine x equals to the plus k, so it's like root 5 minus 1 on 4, because x is between, oh sorry, no equal sign, right? 0 and part 2. Yeah, it's in the first quadrant. So, and I think that's what they want to prove. Yep, perfect. Done. Guys, that's 3 marks, right? So that in itself looks a bit daunting because it's like, you're solving something that isn't like easy SOHCAHTOA, right? But that's how you do it, right? Not too bad. Now, part 2, verify that x equals to pi on 10 is a solution. So it feels like I just sub it in, right? Whenever they say verify, I just sub it in. So I'm going to go, let's have a look, right? So part 2, when x equals to pi on 10. Yeah. So then left-hand side equals to cos 3x, which equals to cos 3 pi on 10. Now, I need to prove that equals to sine 2 pi, right? Sine 2 pi. And we know that the relationship between cos and sine, right? To make cos equal to sine, so I know that cos theta equals to sine pi on 2 or 90 minus theta, right? So then that's cos theta right now, so that would equal to sine pi on 2 minus 3 pi on 10. And guys, I'm hoping that, and it is, right? Because that's like 5 pi on 10. That equals to sine 2 pi on 10, which equals to sine 2x, which equals the right-hand side. Perfect. Yeah. So, let me make it. That's fine. So therefore, cos 3 pi, that's 3x. So, therefore, x equals to pi on 10 is a solution. Yep. Pretty easy. So sub that in, use the identity, right? That cos equals to sine 90 minus theta, right? They're complementary to do it. Now, last part. So right now, 4 marks down, 3 more to go. What's it saying? Prove that. Okay. So maybe it's in the left-hand side, right-hand side thing. So using the 2 parts before it, right? So part 3, left-hand side equals to sine pi on 5 and cos pi on 10. Is that right? Okay. Now, I know that pi on 10 is the angle that I needed to use, right? Because that's part 2, right? It's a solution to. So basically, this is a game, right? Let me go back to the question, right? They've told me, or I've proven that pi on 10 is a solution to this. And if it is a solution to this, I can basically sub that into there. So sine pi on 10 equals to this. That's basically what they're saying, right? By combining the 2 above. Sine pi on 10 equals to root 5 minus 1 and 4, right? That's the key, right? That's the key. So if that's the key, then I need to basically try to find expressions on this one to make it sine pi on 10. Right now I have sine pi on 5, which is double, right? That's the double angle, right? So just to be clear what I'm trying to tell you here, right? This guy here, right? This guy here is equal to sine double angle, right? 2 times pi on 10. Yeah, cos pi on 10. And with this equaling to that, we then basically replace that with the double angle formula, which is 2 sine of the single angle, cos of the single angle, right? Times another cos pi on 10. Now, this is good because now I have the ability to sub in what I want for here, right? So this guy here is equal to root 5 minus 1 on 4, right? From part A. And then this guy over here becomes cos squared, which I can turn into sine squared. And then I sub it in again, and then it's just numerical simplification, right? So if I replace that as root 5 minus 1 on 4, this guy here is cos squared, right? Just to be clear, that equals to cos squared, which equals to 1 minus sine squared, right? So then if it's 1 minus sine squared, I would sub in 1 minus root 5 minus 1 on 4 squared. Now, theoretically, at this point, if I punch in my calculator, it should give me root 5 on 4, right? But I guess they need you to simplify that and actually show that. Does it say without a calculator? Oh, it does say without a calculator. Okay, cool. So they just need to simplify, right? So equals to 2, okay, root 5 minus 1 on 4. Guys, expand that, right? And maybe comment in there, so to be all over 16, that's 16 minus perfect square expansion will be what, 5 minus 2 root 5 plus 1. Okay. Now that will cancel that to leave 2. So if I put everything sort of together there, 2 times 32. And the top there would be root 5, oops, minus 1. And this will be what, 16 minus 6. Is it? So that's 10 minus plus 2 root 5. Yeah, so maybe that it's a bit big. I think I've done something wrong. Have I? Oh no, I haven't. No, it doesn't look like it actually. So just clean this up by making it like that. Oh, yep, no, it's nice. No, it is actually quite nice. Because then when from this bracket, factorize the 2 out, right? If you take out a 2, comes root 5 minus 1. And this is root 5. Whoa. What have I done? Oh no, factorizing the 2 out, so it's root 5 plus 5. Wait a second. Oh yeah, no, plus 5. Yeah, it's still right, it's still right. Okay. All over 32. Yep. So this cancels out of this. And just the concept is easy, right? But just sometimes like silly errors, right? So let's expand this. That's 5 plus 5 root 5 minus root 5 minus 5. Yep, perfect. So then the 5s cancel out. And you get 4, amazing, 4 root 5 over 16, which equals to root 5 on 4, which is the right hand side. Guys, that question wasn't hard, right? It's the last question, 7 marks. Can be a little bit intimidating. If you didn't know what you're trying to do, that's how you do it. Hopefully that was nice, guys. If you like that, like the video, subscribe to the channel, and tell your friends. Thank you very much. I'll see you at the next one.